Hello there. My name is Mohammed Shahat. I hope you find the demo today useful, and thank you so much for listening in. If you have any questions after the demo, please feel free to reach out. I'm part of the Machine Identity Security Business Unit, and I'm a technologist based out of London, covering all EMEA, with a focus on all the non-core products, especially with all the focus on cloud native things like Kubernetes, Service Mesh, multi-cloud, DevSecOps, and applications and microservices, generally speaking. So in today's session, I'm gonna share with you a common use case we've been helping customers, and we have had very good technical buy-in rate. And it's all about people, organizations who are using Service Mesh to cater for mutual TLS and end-to-end encryption. And that's all about replacing the default self-signed certificates with enterprise-approved ones. And the focus today is Red Hat OpenShift Service Mesh. Service mesh is a very widely adopted abstraction of Kubernetes, and people use it for a variety of benefits. But primarily today, we're going to be considering the policy-driven mutual TLS or end-to-end and workload-to-workload encryption in a single cluster or multi-cluster. There are some challenges related to that, and Istio out of the box, which is OpenShift Service Mesh is based on Istio, uses the default certificates that are self-signed, and usually that's non-compliant by enterprise security policies, and it's usually an auditing finding and something that needs to be solved for. There are a couple of other challenges that are non-functional. So the availability of private CAs are usually a challenge because many times it takes down time or unavailable over weekends for patching and upgrades and so forth, but also the increased latency for signing certificates, which are okay for traditional long-lived, but not really okay for ephemeral and short-lived certificates. And the volume that needs to happen, especially with a lot of spikes for service mesh use cases. The Venafi solution, at its heart, does address that. So it replaces the default self-signed certificates with enterprise-approved certificates, and that's through an edge CA or a distributed CA, which happens to be Firefly, deployed in every cluster, very close to the workload, and that helps with single cluster use cases, multi-cluster use cases, and also workloads deployed on in traditional infrastructure. The product mix used in that solution is Venafi TLS Protect for Kubernetes, which includes Enterprise Threat Manager, that's the logo, and Venafi Firefly. The demo setup is that I've prepared for the demo today is using the latest OpenShift container platform, the latest service mesh, and I'm using an enterprise CA represented by our built-in CA. That's something can be used for dev and test that is provided as part of the TLS Protect Cloud, and also an arbitrary company called Acme that I've configured the Firefly policy for. So the flow will go on as following. We will deploy a sample app without service mesh. We're going to inspect it, and then we will deploy a service mesh control plane, and then deploy the same app again and see what is the difference. So let's get going. To help you visualize things, I will run this UI that shows you what's happening in Kubernetes. Let's deploy book info app. Multiple microservices coming alive. The key observation I'd like you to walk away with is that each pod has a single container, which is basically the container for the app. Let's remove that and let's deploy a service mesh control plane. Now Istio is running, so let's deploy our app again and let's see what's the difference. Now you can see that every pod or every component of this microservice application now has two containers instead of one. What's happening is Istio is injecting a sidecar for each of them that is responsible for this east and west traffic, and also like north and south traffic in this case, which called the Istio proxy. Couple of things. I told you that it's using a self-signed CA. Let's inspect that. So you can see cluster.local, which is self-signed issuer, and it's and both are it's basically a self-signed CA and CA equals true. Let's inspect the workload itself. Okay. and we will see that this is being signed by that CE file, and that's what we don't want. So let's now delete this app again, and let's recap. So self-signed CA and the workload sidecars are using self-signed. That's what we want. Let's deploy the Verify operator. The Verify solution now is running. So let's deploy the service mesh again. Now let's deploy the app again. And of course we have out of two. Let's now inspect the sidecar secret and see what certificate is being signed. You can see here the Acme details, the Acme company details, as defined by the Firefly issuing policy. And that's exactly what we need to achieve. Additionally, SPIFFY identifier or SVEDs are also being added to the certificates, which means we can participate as part of a SPIFFY network. So if we recap, we deployed the Venafi Firefly Cert Manager and Cert Manager STCSR. We have deployed the service mesh again with that with the integration, and we have deployed the sample, and successfully we've had certificates signed by the enterprise CA. The value really in summary for security teams is all about compliance. So having the central policies being applied, ensuring compliance and mitigating any auditing findings. And for platform teams, it's all about achieving what the need, continuing to do exactly the same in a transparent way, but the difference is fully compliant and fully functional use case set up, whether functionally or non-functionally. Thank you so much. These are some useful resources. Please let me know if you have any questions. Thank you.